In this third lesson on writing the equation of a line, we're going to learn how to write the equations of lines that are either parallel to or perpendicular to a line that we already know. There's two things that we need to remember about parallel lines and perpendicular lines. First, lines that are parallel have the same slope. And I'll try to draw two perfectly parallel lines here so that you can see they have the same steepness and they have the same direction. So if this line has a slope of 3, that means this line has a slope of 3 also. Next, lines that are perpendicular have slopes that are opposite reciprocals, and we saw what that means in a previous video. Perpendicular lines cross at perfectly right angles. So here I've got a horizontal line and a vertical line, and of course those would cross at a 90-degree angle. We don't have to have a vertical line and a horizontal line. They could be slanted lines that still cross at that perfect 90-degree angle. So these lines are perpendicular to each other, and we know that their slopes have to be opposite reciprocals. So if this line had a slope of, say, positive 2, that would mean this line has a slope of negative 1/2. Now, a few other things to keep in mind as we work here. All vertical lines are parallel. So vertical lines are all parallel to one another. If I have a vertical line, then the line parallel to that is also a vertical line. The same is true about horizontal lines. All horizontal lines are parallel. So if I have a horizontal line, then the line parallel to that is also a horizontal line. And the last note is that the line perpendicular to a horizontal line is going to be a vertical line, and vice versa. So just like in this picture, if I have a horizontal line, then the line perpendicular to that has to be a vertical line, and vice versa. Okay? So now let's remember, when we want to write the equation of a line, we need to be able to find the slope of the line and the y-intercept for the line. So we're looking for M and we're looking for B. That doesn't change. The way we find these two numbers is going to be slightly different for these kinds of problems. Alright, in this first example, we want to find the equation of the line that is parallel to x plus 3y equals 12, and that also passes through the point -3, 8. Our answer is to be written in the slope-intercept form. So we want to find the equation of a line that's parallel to this one. That means we need to find the slope of the line and we need to find the y-intercept for the line. Okay, so to find the slope of our line, we use the fact that it's parallel to this line. Since it's parallel to this line, it has the same slope as this line. So in order to find the slope of our line, we have to find the slope of this line. Let's rewrite this line in slope-intercept form so that we can see what our slope is going to be. So if we subtract the x from both sides, we get 3y is equal to -x plus 12. And then to get y by itself, we need to divide through by 3 on both sides. So we have y is equal to, the coefficient for the x here is a -1, so this is -1/3 times x plus 4. And so the slope that we're looking for is -1/3. So we found M. Now we need to find B. We can find B by plugging in the point that we know is on the line to our slope-intercept form, just like we did before. Our x is -3 and our y is 8, and we know this point is on the line because it tells us that it passes through this point. So when we plug in 8 for y, we know that x is -3, and we found our slope, which is -1/3. So with all of that plugged in, we can now just solve for B. So let's do the work here. -3 times -1/3. -3 is the same as -3/1, and those 3's will cancel. And so we're left with +1. Subtracting the 1 from both sides gives us 7 for B. So we've got the slope of our line and we've got the y-intercept for our line. We can now write the slope-intercept form. Y equals -1/3 times x plus 7. And this is the line we were looking for. This is the equation for the line that is parallel to x plus 3y equals 12, and it also passes through the point -3, 8. In this case, we found our slope by using the fact that this line is parallel to the line that we were given. Now let's look at this next problem. It says find the equation of the line parallel to x equals 5 that passes through the point -4, 12. So again, we're asked to find the equation of a line. What do we know about our line? We know that our line is parallel to x equals 5. And we also know that our line passes through the point -4, 12. Okay, so we know our line is parallel to x equals 5. That means our line has the same slope as the line x equals 5. Did you notice that x equals 5 is a vertical line? Since our line is parallel to a vertical line, we're looking for another vertical line. And that makes finding our equation a lot easier. We are looking for a vertical line that passes through -4, 12. Since a vertical line always has the form x is equal to a number, we know that our line has the equation x is equal to -4. In this problem, since we knew that our line was parallel to a vertical line, we realized that we were just looking for another vertical line. Let's look at this next example. Find the equation of the line perpendicular to y equals 2 that passes through the point 4, 8. Again, we need to think about the slope of our line and the y-intercept of our line. The line we're looking for is perpendicular to y equals 2. hey, y equals 2 is a horizontal line. Since we're looking for something perpendicular to a horizontal line, we must be looking for a vertical line. So again, in this question, the line we want is a vertical line. That means it has the form x is equal to some number, and since our line passes through the point 4, 8, the equation for our vertical line must be x is equal to 4. So these two problems were kind of simple. We used the fact that all vertical lines are parallel for this one. And for this one, we used the fact that if our line is horizontal, the line perpendicular to it must be vertical. In this last example, we're going to again find the equation of a line perpendicular to a line that we know. In this case, the line that we know is y equals 17x minus 8. So we want to find the equation of a line perpendicular to that passes through the point 2, 4. So there are no shortcuts here. We have to do the work. To find the slope of our line, we use the fact that our line is perpendicular to this one. Okay, since our line is perpendicular to this one, the slope of our line is the opposite reciprocal of the slope of this line. This line has a slope that's easy to see since the equation is already in slope-intercept form. The slope of this line is 17. And the opposite reciprocal of 17 is negative 1 over 17. So this is the slope of the line that we are trying to find. Now let's find the y-intercept, b. We know that our line passes through the point 2, 4. So we'll plug in that point along with the slope that we just found. Y equals mx plus b. Y is 4. M is negative 1 over 17. X is 2. And b is what we're trying to find. So let's do the math now. Negative 1 over 17 times 2. 2 is the same as 2 over 1. Nothing cancels here, so if we do numerator times numerator and denominator times denominator, we get negative 2 over 17. And now, to get b by itself, we'll have to add 2/17 to both sides. And in a previous video, you saw how to add these two numbers in your calculator. If you go ahead and do the arithmetic for that, 4 plus 2 over 17 comes out to be 70 over 17. And then on the right-hand side, we're just left with b. So b is equal to 70 over 17. Now we're ready to write the equation of our line. Y is equal to the slope, which is 1 over 17, times x, plus b, which is 70 over 17. And we're done. So again, in this problem, We found the equation of our line by finding its slope and finding its y-intercept. To find the slope, we had to use the fact that the line we wanted was perpendicular to this line here. Finding the y-intercept worked just the same as before. Make sure that you practice enough homework problems to get used to this process, and also make sure that you've memorized these special properties for parallel lines and perpendicular lines.